Hello. In the today's lecture, I will let you know about the combinational logic circuits of paper logical organization of computer. First of all, I will let you know what are combinational circuit. Combinational logic circuits are the circuits which are designed by using logic gates and their output at a specified time depends on input. These are designed by using various logic gates, basic gates, that is AND, OR, NOT, universal gates, NAND, NOR, XOR, XNOR. A combinational circuit, when we design, first of all, we should know how many number of inputs will be in the circuits and corresponding to these inputs, how many outputs will be. As shown in the figure, we are looking that the circuit have m inputs and n outputs. Similarly, once we know about the block diagram of a circuit, we can easily design its circuit diagram using the gates. In the below mentioned gate, you can see it has three inputs A, B, C and three logic gates. One is the NAND gate and other is NOR gate, and output of these along with C is combined with the AND gate, and finally we receive the output A dot B complement dot A plus B complement dot C. Once we have a Boolean expression for the output, we can draw the truth table. As we know, truth table is nothing but the relationship between various inputs and their corresponding output for a Boolean expression. So what are the characteristics of a combinational circuit? Output always depends upon input. It has no memory element. It means we cannot store any data in these combination circuit. They can be designed very easily. They require more hardware to design. As they require more hardware to design, it means lot of logical gates are required and hence they are expensive. They are faster in speed. Now, how these are designed? To design a logic circuit, we should follow all the steps given as. First, state the problem. By state the problem, we mean what we want, what type of logical circuit we want. Then, based on the problem, we determine how many inputs are required, and corresponding to these input, how many output should be needed. Then, based on these inputs and outputs, we name each input by a symbol, generally a capital alphabet, and name the output also. After that, we draw the block diagram as shown in the previous slide, that the circuit has n inputs and m output. Once we design the block diagram, which shows the number of input and the required output, we derive the truth table for each possible input. Then we make Boolean expression for each output. After that, once we have the Boolean expression, we simplify each Boolean expression using Boolean algebra or K-map. Once the Boolean expression is simplified, the simplified Boolean expression is converted into logical circuit diagram. There are a number of combination circuit. For example, half adder, full adder, half subtractor, full subtractor, multiplexer, demultiplexer, decoder, encoder, converter, etc. Lot of combination circuit exist, which we will study or let you know in the next presentations. So first of all, we discuss about the half adder. What is half adder? Half adder is a combinational circuit which has two input and two output. It is designed to add two single bits. The circuit has two outputs, sum and carry. Because as the definition shows, it adds 2 bit, so the value of 2 bit can be 0 0, 0 1, 1 0 or 1 1. So whenever we add 2 bit, the answer can be in single bit or in 2 bit. When the answer is in 2 bit, it means there is some carry. So that is why the circuit diagram has two outputs, sum and carry. This is the block diagram of the half adder. A and B are the inputs and it has two output, sum and carry. Sum is the sum of A and B and carry is the carry received when we add these two bits. Based on these two inputs and output, we can find out what will be the sum and carry. As we know, in case of two inputs, the possible input for two variable are 4. They can be 0 0, they can be 0 1, they can be 1 0 or they can be 1 1. When the input is 0 0, their sum will be 0 and there is no carry. So the value of carry is also 0 in the first row. In the second row, it means that the value of A and B, that is inputs, are 0 and 1. So when we add them, sum will be 1 and no carry will be produced. Similarly, in case of third row, when the input are 1 and 0, value of A is 1 and B is 0, then their sum will be 1 and carry will be 0. Similarly, when the value of A is 1 and B is also 1, and we add them, 1 plus 1 is 1 0, so their sum will be 0 and carry is 1. So after designing the truth table, we can derive the Boolean expression for all outputs, that is S and C. For designing the output, we have to see where we received 1. That means where is the output? Output is in second and third row. Output means where we receive the value 1 in the column. For S, it is received twice at the second and third row. So expression for output S will be the one is produced when input is 0, the value of A is 0 and B is 1. So expression for this 1 will be A complement B. We write complement of the variable when it is 0 and simple when there is 1. So for the first one in second row, value is A complement B, and for the third row it is A complement B. So the number of ones present in the column for an output will be the number of term. As there are 1 in this column, it means there are 2 terms, and these 2 terms are written in the form of inputs, that is A and B. So the first term is A complement B and the second term is AB complement. This can also be written as A XOR B. This is the same output. Similarly, in case of output C, we see that there is only one 1 and that is present in the last row. So the expression for this will be A, B, as both these inputs are 1 1. So the expression is A, B. So once we design the expression for all the outputs, we draw the circuit diagrams. As we see in the previous slide, the value of S is A XOR B and the value of C is AB. So the circuit diagram using the gates are as shown. A, B are the inputs and we give it to XOR gate, it will produce S, and the end of A and B will produce the C. Similarly, we can design circuit diagram of half adder in various ways. You can also design the circuit diagram using NAND gate. As we know, the two-level implementation of NAND gate. Similarly, we can design the circuit diagram of half adder using NOR gate. These are the two figures which shows the circuit diagram of half adder using NAND gate and NOR gate. Thanks for watching my video.